So now that we have sort of an idea of what pin we want to drive out of the microcontroller, which is pin 13, we need to configure that pin to be an output in this setup section. So let's go to the reference, and as you look at this more and more, you'll kind of see some stuff that might make sense. I can tell you right now that pin mode is what we're going to use to do that. So if we go click in that, we look at the function, you pick the pin number followed by the mode, and in this case we want to use output as our mode, and the pin number will be pin 13. So let's go in here and let's type pin mode 13, comma, output. And each time you put a function in, you need to put a semicolon at the end of it. So is this correct? Let's take a look again. No, I have the cases wrong on pin and mode. And one thing you need to know about this language is it's case sensitive. So let's put pin there. Okay, so and also you can tell that you've typed it incorrectly because then it turns the color of the function name to this color. So by clicking on this, we can verify that this code so far makes sense. Does not make sense. All right, so this is where you'll find errors. We got to select the board. So that would be up here. And we know our board is the Uno. So let's select the Uno. And now let's try that. So success. So now we've configured pin 13 as an output. So next we want to actually do something in the loop portion of our code, and we want to write a value to that pin number. So if we go back to the Arduino reference, we can look for a function that will write to the I/O. So digital write is what we want, and you can write a high or low value since it's a digital output, which either is high or low. And if we go down further, we see you put the pin number followed by the value. So let's go do that. So in here we'll say digital write. And notice it goes red, which means it's spelled correctly and it's got the right case sensitivity. So we'll go like that. We'll high. And that'll turn the LED on. But we probably want to actually see more than that. We want to see it turn on and off. So what we'll do is we'll just copy and paste this and then put low here on that one. But this will happen so fast, so what we'll actually want is some kind of a delay between there. So let's go back to the reference and see if there's anything that we can use for delay timing. So let's try this function here, delay. So what you do is you just put the number of milliseconds in the bracket. So let's try that. Let's try 100 milliseconds. High, and then we'll copy and paste that. And we'll make it low for 100 milliseconds. So what the code should do, we'll compile that and see if that works. It should set the pin to output. It should write high to pin 13, wait 100 milliseconds, which is 1/10 of a second, and then set it low, and then wait, and then just loop for this over and over again. So the way we try this on the board is, if you look down here on the circuit board, I'm going to plug this into the USB port, like so. And notice how the lights are turned, the power light is on. So now we click the upload button, and it's going to connect to the Arduino and upload the code. And you see here's the console port. It gives you all your relevant messages. So uploading was successful. So let's take a look at it, see how the LED is flashing. So when you first plugged in the Arduino board, it was flashing. So how do we really know that it's our code? Well, one thing we can do is make a change to the code so that it's very obvious. So we'll add to the delay. So now it's a full second. And also notice that the video camera that I'm using to aim at the board is 60 Hertz, and this is probably around there. So you're not seeing a really good consistent rate. But with a second on and off, you'll be able to see that. So let's see what it does. Okay, so that's clearly about a second on and a second off. So we can be sure that the code we wrote and downloaded is actually running on the board.